I'll bring it back to the point where your bottleneck is analytics. You need that lead time to get the data warehouse up and running.
Yeah.
And one is lead time, and the other is that during the lead time, there's a certain velocity of how quickly things move, how quickly new imports appear in the data warehouse. But one thing that I haven't really seen mentioned a lot is that data warehouse exists in a very changing environment. Because software engineering, the purpose of software engineering from this point of view is to make changes.
Yes.
Yep.
The faster you move, the faster you learn, the faster you make changes in your product, the more chance you survive as a company.
Yep.
Yeah.
And most of those changes involve data.
Yes, because you will evolve your data model, of course.
Yes,
as you
exactly.
go.
Like a new feature kind of by definition involves some changes in data.
In this episode, I talked to Lauri Koobas. Lauri Koobas is the head of data platform at Bondora, and he previously worked in such companies as Microsoft and Starship. And with Lauri, we talked about data engineering. We mostly focused on the data warehouse aspect, starting from the early phases of the company, when you have very little resources, but you still might have some data warehouse, data analytics needs, up to the stages where the company grows, becomes much bigger, and where your data changes need as well. And we talked about all these concepts both from the data engineering perspective and software engineering perspective, and what each of us in their respective fields should know about data engineering, for example, to the things related when building the data warehouse. And we also talked about these tools in contrast with tools that might serve a little bit other purposes. For example, how data warehouse, in-house data warehouse compares to some front-end analytics tools like PostHog or Amplitude, or other real-time monitoring like Prometheus plus Grafana combinations, for example. I hope you liked this discussion. I enjoyed talking to Lauri, and enjoy this podcast. Okay, I am recording actually.
Okay.
I just wanted to make sure for that. So, thanks for visiting the Map for Engineers podcast and being on this episode, Lauri.
Thank you for inviting me.
Yeah. So actually, why don't you tell me and us what do we want to talk about? Because, well, we discussed it, but I think the topic is very interesting. So maybe actually you can make introduction to that.
Sure. I've been a data engineer for about 10 years-ish in various different data roles. And being a data engineer always involves working with software engineers because that's where the data usually comes from in product companies. And there are things I've learned over the years, both about software engineering and also taught software engineers about data engineering, what's relevant in that regard. So that's where this kind of came about.
And yeah, I guess it's a good dynamics we might have today, because I am a software engineer by trade and you're a data engineer by trade, right? And one topic we will explore is what software engineers should know about data engineering, and vice versa, what data engineering should know about software engineering, and maybe how to create good synergy between us in our industry. And it might also manifest in different people working together, right, from data engineering and software engineering, or even it can manifest in one person to understand, and again, as you said, in a product company, even when it's, again, in one person, which skills do they need to have in software engineering, but then also in data engineering when they're building their company, right?
Yep.
So, and that's very interesting. And I think the good place to start would be to actually explore your background and where you are coming from. So you said you're a data engineer by trade. Can you tell us what has been your journey in your career?
I kind of let's call it I'm software engineering by trade, in the sense that my first 15 years or so I was in software engineering. I'm quite old.
You have very young energy, though.
Thanks.
Yeah.
My first job as a software engineer was in late 90s.
Right. I was born in late 90s.
Yes.
Disclaimer.
Yep. And my career actually started in Hansabank, which later turned into Swedbank.
In Estonia, right?
In Estonia. Yep. Where I wrote Oracle forms and reports.
Oh, wow. I was lucky enough to never touch Oracle in my life.
Yep.
Well, I touched Java, but that's the only thing that I touched.
But that's
from
also
Oracle.
like I essentially started with data.
Yeah.
Without any understanding of what it was, how to work with it. But like Oracle forms and reports is about recording like data input and data output.
Yeah.
And the functionality was written into PL SQL database functions, essentially. Was a rough going with a lot of training available or books. It was just learning by doing and
Right. So
from people around me.
It was the start of your journey. And did you do like software engineering in a classical sense, like building features, programming something? Or it was still more on this data side still, right? From the
I was there for 6 years, so I moved around quite a bit. I was at one point also part of a large migration from, I think it was Internet Explorer 4 to 4.5, something like that. And the 4.5 was when they introduced Ajax, which made things a whole lot more interesting, so you could submit forms without page loading, that kind of stuff. And that was literally like 2001 or 2, something like that.
.com bubble.
Yeah. I also worked on the year 2K problem.
Which problem?
Year 2000 problem.
Oh, you did that?
Yeah.
Wow.
Yep.
I only read it in books, but I actually now talk to the person who worked on it.
Yep. What was interesting and fun was that Hansabank at the time essentially was a software. It was the largest software company in Estonia at the time, with like 200 people working in software. And it's a banking system. It can't really crash. So what they did was they actually had a Christmas party for all of the employees and their families within the bank itself when it went from 1999 to 2000.
Right.
And then some groups of people, so that everyone was available in case bad things happened in the software.
Wow. Smart move.
With the year change. Only small things happened. Nothing touched me personally.
Cool.
But yeah, everyone was there. We were watching the
That's a cool
the
trivia
fireworks from the top of the Swedbank building.
Okay.
That was fun. That's
Yeah.
like ancient history.
Right. Is it right to say like that, you know, of course in Estonia we know about Skype Mafia, where many people from Skype turned to create great companies. Ahti created Starship, Taavet and well, Kristo Karman founded TransferWise and many other things. Like a lot more money appeared in the tech industry, right? Because people had money to invest into new companies. You also worked in Skype, right?
I did. At a much later date, but yes.
Right. And just to bring parallels, would you say this early 90s and the Hansabank was also sort of a good ecosystem where a lot of talented individuals later created different companies? I'll give an example. I know Anton Keks, Alvar Lundberg, they went on to create Codeborn, and then Alvar went to lead Wise Engineering. And then some people joined Skype. So a lot of good things happened because of that Hansabank and the amount of talent that was there, let's say.
Yep, exactly correct. The Skype actually posted their job ad as a billboard in front of the Hansabank building at the time.
Wow,
Or
that's
it
close
was
to them.
Swedbank at the time, but yeah, a lot of people actually
I didn't know
went
that.
from Swedbank to Skype.
You including?
No, I was much later.
Okay.
But few companies came out of it directly as well. Icefire was one of them, which now has turned into Doom, and some of it was bought and is now checkout.com. And later many different things. Avalanche Laboratories is, for example, one service company in the data engineering space, and the founders came directly from Swedbank data warehouse. And many others. It's just the ones that I know off the top of my head. But life from there went into weird ways for a bit. And after a couple of years, I ended up actually as a web developer.
Oh, I didn't know that.
Without knowing PHP beforehand, but I learned on the job. And I was a web developer for 6 years.
Oh, wow, cool.
We did
Consultants company?
Yes. They had their own CMS software, and then later transitioned to be the Drupal experts in Estonia. And at one point, I was the lone maintainer of both Estonian Air website and the main maintainer on the technical side of Tartu University website.
No pressure.
It actually, because it allowed, I was doing remote work in 2009.
Oh, wow. Okay.
Yeah, I went to school at the same time full time, and I was able to do everything at the same time.
Nice.
Mostly remotely. So I've done a lot of software engineering, but not in the sense of building features or doing domain-driven development or test-driven development or these areas. But from then on came the first open online courses.
Yeah, massive open online courses.
Yep.
I remember the movement very well.
term
2012.
The term was coined after the first one.
Yes.
The first one was actually AI-based, about autonomous driving.
On Udacity.
No, Udacity was a website that was created afterwards.
Yeah, exactly. But it was the who was the guy?
AI class.
Stanford professor.
Yeah,
Sebastian.
Sebastian Tron and someone else.
I watched that, by the way.
Okay.
Yeah.
Yeah, I participated in the first flight of this.
Oh, cool. Wow.
And that was very interesting. I was working full time, going to school full time, and then took this on. And I remember spending a weekend trying to recall and or learn
about Kalman filters,
matrix multiplication, and like those
how Kalman
things.
filters work or whatnot.
Yeah. That was fun. And quickly afterwards, because the first AI class there, they expected a few hundred, they had like 80,000 participants. And they quickly...
That escalated quickly.
Yeah, that escalated quickly. And that escalated into several different companies with their open courses.
Yes.
So for...
edX, Coursera, Udacity, for example.
Yep, the main three at that time. And I took a lot of that was just put in there and created for it. I think I've at one point counted the ones I completed about 20 courses in the span of 2 years, and most of it led to data science. And at the same time, there was still the Kaggle machine learning competitions.
Right.
And I participated somewhat in those as well, but that was rough going.
Wild West.
Wild West. I learned a lot doing it. Which coincided with the data science hype. So I had someone I knew working in Skype in anti-fraud, and I mentioned that, I'm doing the data science courses and self-studying in this area. And they said, we have a position possibly. How Skype worked at the time, it was freshly part of Microsoft. And big guys in London went to conferences. And in the conferences, right now, it's AI everywhere. Then it was data science everywhere.
Yeah.
So they were like, we need a guy to do something with data.
Yeah.
I turned out to be that guy then.
Right. In Skype.
In Skype.
Again, no pressure.
Anti-fraud, yeah. And all the online resources at the time and the Kaggle competitions and so on, it was like, take this, then run it, and it works. And it turned out, yes, it kind of works, but only with toy data sets.
Not in production.
No, I'll get there.
Yeah.
But for example, in machine learning, you have classification algorithms.
Yeah.
Except at the time, none of those handled classifying things where the class imbalance is like 1 fraud, 1,000 non-fraud.
Yeah.
Yeah, it mostly handles like, you have 30% something and 70% of something else, so let's classify. But if it's 1 to 1,000, then if you always predict something, then you're correct 99.9% of the time.
Yeah. It's this recall problem, like the false positive problem, right, versus false negatives, for example, or...
Yep, a lot of that. And the other problem was that if your class imbalance is that large, you need a lot of data. So pretty much none of the tools handled like 6 million transactions or something like that. It was all meant for like up to a few 100,000. So it was a like rough going learning by failing a lot. But learning. And that's how I actually ended up in data. I started as a data scientist, and my position at one point was called R&D engineer,
Right.
something like that, which essentially was data engineering.
Right.
I was in Skype for 3 years and saw small white robots drive around the building because Starship was essentially in the next building.
Right.
So everyone was interested in that. At first, they were hiring PhDs with
Computer vision knowledge.
With computer vision knowledge, and I just essentially went there and told a couple of people that if you need SQL, let me know. And like a year and a half or so later, they started to build a data warehouse, and I became part of that.
Cool. And may I ask you, you mentioned that you worked as a data scientist in Skype, but again, the terms were kind of used interdependently. Data science was the term that used. And then you mentioned the term data engineering and that you worked with machine learning. If you take these 3 terminologies or 3 words, machine learning, data science, and data engineering, how would you describe 3 of them and how they interrelate with each other and the commonalities and differences? Because again, this sometimes are very overloaded words and they're used kind of sometimes lightly.
I'll come back to that.
Sure.
I have a mental model for this, but it starts further away.
Yes. Yeah.
So a company that
starts with a problem, right? Not solutions.
It starts with a problem.
Yes.
You have a company, you have some data. In today's world, very large majority of companies have some data. And at one point you figure out, let's look at stuff.
Yeah.
How did we do last month? Okay, you can do that in Excel, in your, bank account, something like that. And you gather more data, and then it's, what kind of customer service problems we had yesterday? And then you hire a data analyst because there's apparently value in looking at what's going on.
Yeah.
And you have data analysts, and that can work for a very long time, especially if the company isn't growing very fast. But eventually you will arrive at a place where you have a lot more analytics questions than the analysts can answer, because every time the analyst needs to go start from scratch, essentially, figure out where the data lives in production or external API and so on. And the bottleneck then is, how do we get data to the central place?
Yeah, that's where data warehouse comes in.
That's where data warehouse comes in. And yeah.
Let's have it as a teaser to the upcoming topic that let's discuss this. Yes, I really like this idea of discussing and this was also actually in my mind before we started the podcast, to discuss, yes, the natural progression, the growth of the company, and how data engineering plays the role there. Right?
Yep. But at that point, the machine learning and all of that is not even in consideration.
Yes,
but we can come back to that.
And let's say, and you mentioned that you, after Skype, joined Starship. And let's also maybe discuss that a little bit, because I think, well, you can tell us, Starship has very interesting requirements or constraints and problems, challenges related to data, right? And the whole data processing and the amount of data and the scale that is there. Maybe you can talk about how you grew in Starship and what you learned in Starship that you may share with us.
Okay. Starship, I'll paint the general picture. Starship, robotics company, has robots. Each robot is essentially a computer on wheels. It has internal hard drive. It records relevant stuff from the surrounding world to help it drive around.
Autonomously.
Yes, as much as autonomously as possible. And that amounts, the sensor data is, some of it is like 30 hertz, 30 times a second. You create a record of something somewhere. So it amounts to many, many gigabytes per day per robot.
Per robot.
Per robot.
And now how many robots Starship operates on daily? Thousands, right?
Yes.
Right now, I think it's thousands.
Yeah.
But let's not get attached to numbers.
I think
we are not working there anymore.
It's definitely more than 1,000.
Yeah.
But I believe less than 10,000. So,
right.
Yep.
Yeah. So we talk about at least terabytes of data per day. I mean, raw data.
Yep.
And now,
Yep. So from data engineering perspective and data warehousing and management perspective, it's what's called a data lake, because you have massive amount of raw data that most of it you actually don't use, but some of it sometimes becomes useful even historically. In the sense that you can only develop things that deal with like slipping on ice when you have data about robots driving on ice.
Yeah.
So if you don't have the previous winter's data, you can't prepare for the upcoming winter with possibly more slippery conditions.
Data was literally like essential. It was a blood, as essential as blood in the human body for Starship to survive and to learn.
Yep. And that's called data lake because it's a lot of raw data, and you just have powerful tools that manage to pull some of it out sometimes when it's needed. And that's the technical part of it. There's also the business part. And the business part is where you came in, you built the products, how they operated, and essentially you end up with, we have a customer, we have order, we have whatever they had in the basket, the store they bought it from, how long the robot drove, and all of this, essentially business data. And that's data warehouse.
Yes.
So the term in recent years has been combined. It's called data lakehouse. So it's a data lake with a warehouse.
Right.
So you have a wide, like a huge amount. In Starship's case, we got to like almost a petabyte, which is 1,000 terabytes of just random technical data. And then you have a warehouse that actually has layers of, this is the raw, timestamps, API timestamps, business data, up until a business dashboard that says how many customers in a university bought burgers yesterday, type stuff. and that goes through analytics layers. And all of this takes fairly different skill sets to build up.
Yeah, and by the way, why you might, let's say, I know you might have had like, oh, I'm going to talk about this, and then carefully we will talk about these topics. I deliberately wanted to have this kind of messy conversation in the beginning to, let's say, on the surface area, to describe that, yeah, in Skype you had certain problems, right? One set of problems, and in Starship you have this like massive scale of data problems.
Yep.
And this is just maybe, you know, a prequel to start with, that, you know, that because the problems are on such a different scale than, I don't know, your simple CRUD application, right, versus your simple CRUD application, which and the data is incomparable, right, and the skill set that you need, or the knowledge that you need, is in a completely different level. It's like building the doghouse versus building a skyscraper.
Yes.
It's a completely different skill set. And what I like is that you've been in software engineering, and then also the data engineering in these different sorts of roles. First, like purely, let's say, maybe business analytics. Let's just, you know, analyze some things. Also data science, machine learning, where you do some maybe feature engineering, right? To I don't know, understand, to again, like for fraud or for other cases. But then you have the Starship, where you just have this massive amount of data, and you have to build this data lakehouse, and then the data warehouse pipeline, and including the business dashboards. So this is just to give the readers maybe, you know, the breadth of like the problem spaces we talk about. But now I'll actually let you to navigate how you want to let this conversation happen next, in terms of the talking about data engineering. So, stage is yours, Lauri.
Okay. When I say granularity, what does that mean for you?
Granularity in which context, I would ask?
In data, but I'll expand from there.
Granularity of data, well, I know you have to be specific which problem we are solving, or, you know, that's always what I ask first.
It's good that I asked this. So granularity in this sense means that in case of robots, you have the sensor measurements, which is very small grain.
Oh yeah, okay. Okay.
Yep, which is very small grain. Not a lot of information in there, but it encapsulates like a very, very small event.
Yes.
And on the very other end is, let's say, revenue of previous year, which is like a very large grain that...
yeah, let's say aggregated data.
Yeah,
already,
like massively aggregated data.
Yeah, I follow.
Yep. The same is with problems. We can talk about data engineering and software engineering on very different granularities. So one is like specific techniques and data types, it's very small grain, and the other is how to build a large organization into a huge organization in terms of software engineering or data engineering, for example. That's a very large grain. With me there?
Yep.
Okay. So I thought through this, what I would present from data engineering side, to start with the small grain, and we can continue from there.
Let's do it. And let's, while we explore these grains, explore it from both data engineering and software engineering sides, and because it's kind of solving some certain problems, right?
Yep.
That we have on the way. Yeah, let's do it.
Okay. I'll actually start with not even the data types. And this is purely based on many years of personal experience. And this kind of feedback to software engineers as well. With your previous guests, you've spoken about Next.js and using database wrappers. ORM, I believe, is the term, object relational mapping.
Oh, yeah.
Yeah, there are libraries that you can write your JavaScript or Go and stuff happens in database. You don't write SQL queries in your code, right?
Oh, we do, actually. There's a thing called repository pattern where you can write SQL queries. You just wrap them up in the repository, and then you, it depends. It could be a complex query. So it depends. Do you have a query? It depends on the result, what the query returns. And you can do both. You can manually write a query that returns you some entities that you then convert from the data model to your domain entities. Let's say you call it, I don't know, in Pactum we would have negotiation as a main entity. So you just fetch it from the database, and how you fetch it, you can use raw SQL, or you can use some ORM tools that will facilitate that for you, let's say, like type ORM, for example. But you can do both. For example, we have actually, again, for example, if you have dashboards in production that you show to the customer eventually, you can wrap them up in the repository. It's called the repository pattern, and you will write a raw SQL query in production code to fetch the result set, and then eventually to propagate it back to the front end, so the front end can do that. So we do both, actually.
Okay. Within that world, what my experience has been is that people mostly use ORM to describe some entities, and then seed the database and tables are being created. And by default, it's nice to read, which means it's capitalized. But if it ends up in Postgres, then the table names are also capitalized and column names are capitalized.
I see.
So writing raw SQL against that from like data person perspective is super cumbersome.
I see.
Like I've seen column names with spaces in them.
Wow. Yeah.
Because in your JavaScript code, you can do that.
Yeah. By the way, just saying well, depends with which engineers which engineers wrote it, right? As always. But yes, actually, in engineering, it's a common practice that you will create table names yourself, and usually you would follow whatever snake case, and you can do it through migrations, right? You apply migration, and actually in migration, or depends in some infrastructure configuration, when you create a table, you literally just write raw SQL saying create table and not this table name. But there are two schools of thoughts. Yes, you can use heavily the tools that automate it for you and create some conventions that again will be cumbersome for data engineers. But actually, I would say more experienced engineers, and those, let's say, I know of and I respect as engineers, and I know they have very good, sharp skills. We prefer to have let's say full control, where we control ourselves, what table names we have, and even I would say also the index names. It's important to have them intuitive. I don't like when index name is auto-generated and is a complete rubbish name, because then, how do you debug that later on? So I like, for example, when I create indexes on a table in database, to do it myself and to name them myself, because it makes sense. But we can continue. Just a small detour.
That's on a very small grain, like a thing that mostly every data engineer will run across at one point, because Postgres is popular, and you need to put quotes around every freaking table name always, and that's bad. The other thing to consider is that every language and database system has different data types in the sense of different precision of timestamps, for example. That was a case in Starship, where MongoDB, if I recall correctly, timestamp precision is 7 digits after the comma. It's like 100 microseconds or something like that. But the data warehouse has either 9 or 6. And the language in between, Golang or Python or something, has a third precision.
Yeah, I follow.
So it's one of those things that if you just write production code, it never comes up.
And the problem appears, correct me if I'm wrong, when some system, first of all, you have this many translation layers, and the problem is that when the precision is lost in those translation layers, but some system after all this processing, relies on a higher precision than
Yep.
already after processing,
Yep.
right? But I guess it's also sometimes an edge case, right? Because most of the time you might be fine with the precision that even that you lost because you still have a lot of kind of decimal places after comma.
Yep, it depends. There's two main cases where it can cause problems. One is just the pure ordering of events. Yep,
Right.
because in your
You
code
can lose the order.
you
Because
can
if
lose
you
the
have
order.
higher precision, you have, let's say, deterministic ordering.
Yep.
But then you lose the precision, and that's where like some events can have the equal ordering, and they
Yep.
can be. And if you again apply sort,
Yep.
you have undefined behavior. Which one?
Yes.
And if you rely on ordering, that's a problem.
Yep.
Yeah.
And the other, in Starship case, especially when you deal with physical devices, then things in electronics happen on nanosecond scale.
Yeah.
And you can't work with that within a data warehouse or like data tools context that only support like millisecond or microsecond precision. Doesn't apply to everything, but still. And yeah, the other is that you get kind of fake data from time to time if things get if the layers have different precision. It seems like you have all of the digits after comma, but some of them are always nulls. Yep, like these things that if you only build production codes, you never come across.
Yes. Yeah.
Same with like text and string sizes, although it's not that much of a problem nowadays. But there are also interesting cases where the case sensitivity of a system is important. For example, Microsoft SQL Server, strings are case insensitive.
Yeah. In database.
Yes, you can write you have values, for example, for a country code, capital E, lowercase e, all the four combinations.
They will all equal to each other in
Yes.
a sense when you compare.
Yep. When you transport that elsewhere and it's not the same case,
Yeah.
you copy it to Postgres or any data warehouse, it doesn't work anymore.
This example, it works on my machine, but doesn't
Yes.
work in production. But in your machine, you have different database, which is not
Yep.
the one in production, and case insensitive. Yeah, I see.
So those things. And like this is the very small grain of things that don't show up if you don't deal with like reading the data and working with the data afterwards.
And just to say, I still think this is very valuable that you are mentioning this, because these are exactly the things, let's say, that we software engineers can be more mindful about when we write production systems, knowing what things can go wrong and knowing to think sometimes, maybe even at the back of our minds, think about case sensitivity, what was the case, timestamp precision, and those things. So yeah, please continue. Just I find it very useful.
And the large main last of those very small granular things is just the like cleaning of the input data.
Yeah.
Yep, like trimming away the leading and trailing spaces and all of those things, because it doesn't affect you in the UI.
Yeah.
But the moment you want to compare an item name in a database, that will have the leading spaces and trailing spaces, and sometimes you can have a line break in between.
And you know why I laughed a bit? Because I know it's a big problem in machine learning pipelines. Cleaning data is one of the hardest things, right? And where do you get data? Well, first you get it from database. And again, if you don't clean it well, your model will perform badly.
Yep, but that's where it's already in database.
Yeah.
But it gets into database from either an external system or from user input.
I agree. So the lesson is for software engineers to ideally pre-clean and only save already cleaned data as much as possible.
Yep.
Of course, at the point where you save it, so you don't save corrupted data or rubbish. And one example is if you can trim data and you know it should be trimmed, always trim it before saving it. It will like make your life easier and create certain invariants that you can work with or rely on later on.
Correct. Same with character sets. Yeah, your UI will allow, I don't know, Turkish characters there,
Yeah.
but maybe it's actually not allowed in the database in the sense, and that's coming from the financial sector
Yeah.
because I don't know where it exactly originates, but you can have a contract with a person. That's why the passports are in Latin alphabet.
Yeah. Yeah.
Yep.
To make sure it's all ASCII.
Yes, exactly.
Yeah.
But that's also a legal thing. If you give a loan to someone who entered their name in a Cyrillic or some other non-Latin character set,
Yeah.
it might invalidate the contract to some extent because you don't know what their correct name in Latin
Yeah.
would be.
Yeah.
And that's at the same time a very granular thing, but also a very product thing. So if you don't know that this needs to happen, you're not going to do it.
Yeah. I can tell you a small, while we are taking a breath, and I'll pour myself a tea. Do you want, by the way, more?
I have some.
I can tell you a story. Well, it's a funny one. I think I can share it. It's nothing sensitive. But when I was working in Voice, I worked as starting my career in Voice pretty much as an engineer. I wrote a bug where I will not go into details, but let's say it was about, as always, when you do the math in double and not cents, you will then lose a precision to the point where, let's say, you can underpay actually. Well, your final result will be, let's say, smaller because you had a lot of previous roundings before.
Yep.
So you lose precision, you add things up. And again, I will not go into specific conditions, but pretty much you end up with the amount of money, and we were like doing the payout calculation, how much we should pay to the, to the person, and we promised them one number on a front end, and we paid out, I think, 1 cent less. And I was at fault for this bug. And this is again to talk about data, because well, it is about data and data flow through your system, right? And I remember, and again, because WISE and transfer culture was really about that, engineers care about customers. I remember I personally wrote an email to that customer, apologized and said, I'm the engineer who introduced that bug.
Okay.
I apologize. We already refunded you this 1 cent because he needed it literally for accounting purposes or something, that it would all add up in his system. And then I remember I fixed the bug and then I wrote back to him and said, look, the bug is fixed. Again, I apologize for you. But that was I still remember this. And now whenever I deal with, let's say, numbers and arithmetic in, adding things up or multiplying or doing anything, I always keep context in mind. Like, okay, what precision we're talking about, and can I lose some information here in terms of precision or not? And how should I deal with it? So yeah, the context is always important, right? When you deal with data. And it comes down back to the business problem. Because we promised this number on the front end to him in the product, you have to make sure, and this is again about software engineering and data engineering, that through your system, you have the same exact number as you promised to in the product. And this is very important. And it's very easy, if you're a software engineer, to lose that context while you are doing your work, but you always have to keep the kind of the problem you're solving in mind and the product in mind. But
the precision, that happens in other places as well. I've run across it in different contexts, especially with the currency conversion rates.
Yes.
That was the business WISE was in, and it depends how much of it to save. And what are your transaction amounts.
And this was exactly my problem. I was dealing with this currency conversion rates, and again, in this arithmetic, something like was just wrong.
I recently helped uncover a bug that actually wasn't a bug. There was some report that was off by like 3 millionth of a percent. Like a very aggregated report, but the numbers don't match up.
And for readers or listeners to also know the context, you are now working in fintech Bondora.
Yes.
And, yeah. So you're dealing with, let's say, critical numbers that should be correct all the time.
Yep. Or at least I sometimes get pulled into these problems, like, because the numbers that don't add up are in the tools that I help maintain and
Yes.
help people use. And then the case there was that, yeah, the currency conversion rate worked for everything, but if you applied it to a large aggregated number, then you lost precision.
Yes. Yes.
And that was the like 3 millionth of a percent
Yeah.
off. And that explained
Yeah.
it.
Makes sense. Okay, so we talked about the small granularity problems and how you like have to keep in mind because they will cause you trouble and problems. What shall we discuss next?
To have the same granularity things from software engineering side that data engineers should know about?
That's a good question. I think actually, I mean, it's the things you mentioned. I would say this is exactly where it's perfect intersection for both. These everything you mentioned about timestamp precision, ordering problems, text strings, understanding case sensitivity, equality, cleaning input data before save, character sets. I would say this perfectly describes the knowledge and things that both data engineers and software engineers should know. So for now, I have nothing to add. Let's move on. But yes, I think in this regard, it's the knowledge that both in our field should know about, which is kind of obvious, but yes, just to stress the point.
Yep. If I may, I'll add something from you, from software engineering to data engineering side. And that's something I came about in Starship, where same with timestamps. And different timestamps, for example, when the event is created in the front end or back end, and when the event ends up in your messaging system, like Kafka, there is a few milliseconds or microseconds delay there, and then it ends up in the data warehouse, and you end up with situations where 2 million events are perfectly within the same date, but like 2 events are in the next date.
I see.
Yeah, if you like count events by date and it's off by 0 or 1 or 2 over a longer time period, and this is where the timestamp precision also comes in.
And it also depends like which timestamp you even consider.
Exactly.
So, and that comes to the semantics of timestamps.
Yep.
So you have to understand, do you generate a timestamp on the sender level and what it means? Or is it generated by Kafka? That means absolutely already different thing because we talk about networks.
Yep.
So yes, here I would say it's important whenever you process any timestamp and rely on any timestamp to understand which system generated this timestamp and what it means and how it differs from other timestamps that may seem very similar or even equal, but not always. And this is where problems are.
And it might seem like 2 old guys nitpicking on problems,
but it's not, right? They're very
it's
important.
Not. And once again, in fintech world, it depends which timestamp do you consider the contract to be signed on.
Yes, 100%.
When does the loan repayments actually start?
Yes, I agree.
And same happens with time zones. If it's an Estonian company that gives a loan in a non-Estonian time zone, where does that actually go? And how do you keep all of that stuff?
And again, as we know in our fields, devil is in the details. And I'm so happy we talk about timestamps because this is very important. So again, just to maybe summarize for myself, I call it like understand the context and semantics of timestamps and which timestamps you rely on. And you have to be very conscious about what you rely on and what you use for. And understand how this timestamp got generated, which precision it has, and all the dependencies in your system to that timestamp.
Yep. And from the product side, what's actually important?
Yeah. And now you asked me the question on software engineering. So I think I wrote down one thing, but maybe you will I'll let you guide in which phase of granularity we will discuss it. So the one problem that I think is very relevant and exactly where the intersection comes in, and we always deal with these problems, is how to move data in production to data warehouse or data analytics systems. So what I mean is that you have a data in production, right? You save it in production in database, and when you're a small startup, that's all you do.
Yep.
Like you even query from the same, cluster.
Yep.
You don't even have replicas or anything. Now the question: how do we move from there to ending up with data in data warehouse or data lakehouse or whatever you call it? And I think this problem is very interesting to explore. Again, up to us when we discuss that, but this is one area I would like to discuss because there's so many options there. Just to give a teaser, you can have or start with API integrations where data warehouse will just call APIs, or you can be event driven. You can organize it on a database level and organize integration where the data will flow directly from the database level. So there's so many trade-offs also in this space. It's a very interesting space for me, at least, to explore.
But let's go there because it can get very wide and detailed. But at the point when that becomes a bottleneck, you have already teams of people.
Yeah.
So from the point of view of like pragmatically from data engineering point of view, the source databases, the production databases, MongoDB, Postgres, all of these, SQL Server and all of them are pretty fine if you just go and query 5 million rows.
Yeah.
They're like, okay, half a second, go ahead, do that. If it's not like a megabyte per row. And that essentially is the end of the problem 99% of the time.
Right.
You just, first of all, you don't need everything in data warehouse. You only need the things that are being used there.
Yeah.
So you don't need to dump the whole production database.
Yes. So if you don't need some crazy attachments, you just don't select them in your SQL query.
Exactly.
Right.
So you need a sub-selection of what's in production, and usually you can just fully import those. So it bypasses all of those other considerations, event-driven or whatnot. If you're just building a SaaS tool or something like that, where you're not going to be extremely data intensive, then that just works.
But let's talk about it because
Okay.
that's a rabbit hole. But I really want to talk about this topic in depth because it's close to my heart, and I think it's why I'm saying this because I deal with these problems every day actually.
Okay.
And also right now in Pactum about let's say the intersect because I'm platform engineering lead. Well, and eventually we need to pipe data to data warehouse, and there are so many trade-offs to do there. It's crazy. So I think it's important for listeners to know about these trade-offs or the options available to do it, and also on different stages of the company.
Oh yeah.
Because it depends. So let's kind of start by saying that, as you said, just to paraphrase, for a small company, you're fine again, not creating any replicas. You just literally query production cluster.
Yeah,
And
your first analytics will always be on the production database.
Yes, just production database. And now when you say analytics and you mentioned the word import, how would you do that in the early phases?
In the early phases, you don't import. You just attach some kind of a visualization tool that...
Let's talk about that. Which one would you recommend or use as a default? Of course, we're not like doing some crazy competitive analysis right now here.
It depends.
Redash?
Redash is an option. I don't think it's being developed that much anymore on the open source side because it was acquired by Databricks a couple of years ago.
So Databricks would be your choice.
But Databricks is a cannon to kill a sparrow.
Right.
So let's Database is a advanced data warehousing tool.
Exactly.
Don't go there.
Yeah. So again, which tool would you use?
But whatever tool you have, as in dbeaver, it's just you can go and query stuff.
Right. So we are not even talking about this analytics tools like Redash.
No, we're
not
talking
even that.
about a thing that lets you connect to the instance and run some queries. Because at the very beginning, you want to understand if something went wrong yesterday.
Yeah. And let's say this is first step. And the next step, let's say you actually want to build some dashboards and save them, pretty much the functionality of Redash, right?
Yep.
What are alternatives to Redash? And for listeners, again, just taking a step back. So what we're talking about is you're past the phase where you just need to randomly make queries on a production database. You're now at the phase where you want to have, let's say, somewhat scalable analytics where you can save your queries, you can save your dashboards on those queries, so visualizations, and you can share them internally in the company to have a shared understanding of how your business is running or some business insights, right? For example, your revenue, number of users, or any business metrics that you follow or KPIs, right? Could be tied to your OKRs if that's what you follow, but probably you're still too small to follow OKRs. Your metrics that you care about. So Redash is one option, what we discussed, and curious to hear from you, what are the other ones that you would recommend? As a default, we're not talking about some definitive answers here.
My other answer is to not do that.
Okay, let's explore that.
But the examples that you brought, revenue, you can see that in the bank.
Sure.
Yep. And if you're building a software tool, then you should actually be instrumenting your software tool with some business events.
Yes.
For example, front-end tracking is very well-developed area. There are
Let's
tools
say
like
PostHog is one tool.
PostHog, yeah, Amplitude, these kinds of tools.
Right.
And you can get very far with analytics just in there.
That's a very good point. Yeah.
Yep. Because
So let's say one analysis is to like use and utilize these tools to the max that they provide you for analytics.
Yep. Because business analytics is for business questions.
Yes.
And if you have a customer-facing tool, then the business activity of the business happens in a tool. So you can instrument that tool to record the business events.
Sure.
Yep. And you can, if that doesn't suffice, you have some backend stuff as well. You can send those there as well to PostHog or Amplitude.
Oh, I see.
Yep.
You can send events manually to those. I didn't know about that, by the way. We use PostHog, but I didn't know you can kind of. Oh yeah, no, I mean it makes sense that they build this functionality. I just didn't know it exists.
It's just it instruments the same API from a different place.
So you can send backend events, data to those tools and use them. So you have one unified tool, which is from again the early start is very lean and good idea to follow.
Yep. And it's essentially real time as well.
Yeah.
Yep. So you are doing what you're doing. I'll bring a different mental model here that fits into this space. Is that you as a software engineer, you're doing technical monitoring, right?
Yes.
You know where your code fails.
Yes.
Yep. And then
we call it also observability or monitoring.
Yep.
Telemetry
but
instrumentation.
It's technical observability.
Yeah.
Yep.
Absolutely.
And then with those like business events, you can do business observability. And then you have business analytics as well, which is like what happened yesterday, more aggregated stuff and so on. And then you also at one point will have technical analytics. We might get there, we might not get there. Technical analytics is, I don't know, your Jira task fulfillment times, and I don't know, your SaaS tool costs and these types of things that are not real time, but are technical, not business related.
I follow.
Right. So coming back to the real-timeness, then you can do quite a lot of business analytics on top of the real-time data or with ad hoc queries. So what I'm saying is that, yes, you can use Redash. You can build your things there. And in addition, you don't need to go to data warehouse. You can utilize your essentially front-end tracking tools
Yes.
for additional analytics.
Yeah. I get it. Yeah.
And that also serves as the business monitoring solution.
Yeah.
Because you usually, depending on the business, it might suffice if you see what happened last day or last week, but usually you want to see also, okay, we put the new feature live, does it actually work? We want to know that within half the hour, not half the day.
Yes.
So, and that's business monitoring too.
Yeah.
Yeah.
Can I simmer in this topic a little bit? Because you mentioned very interesting dichotomy, or you have business analytics and tech analytics. Sometimes these converge, right? An example would be, I mean, it's kind of going technical, but that's why also we have this podcast for engineers, right? We don't just go over the surface. SLOs. You've heard about the term SLOs in engineering. And just for listeners, so the whole idea of SLAs, SLOs, I would say it was mostly propagated and popularized by Google. Google's philosophy on SRE, Service Reliability Engineering. And the point that I would say they made impact in the industry is to say that SLOs, which are service level objectives, should represent your customer experiences, right? For example, your latency in your most critical paths in your product. For example, how fast the landing page loads, right? Or other performance or other sorts of metrics, right? Like latency of critical paths. And now what we programmers usually do, we would use something like a real-time, time series database like Prometheus or Graphite. We will store those metrics there, or now you can do it in Google Cloud, for example, as well, or any other cloud. And we would visualize it in Grafana. And now this is why I'm mentioning this, you will understand. So what we will do, we will represent those SLOs in Grafana, for example, latency of landing page load, right? And we can even build alerts on top of it, right? And that's very cool because you are notified of a regression in user experience before you get a complaint from a customer. This is perfect. Now, what I found in practice, de facto, what happens in the industry, and I think that's not a bad thing. Sometimes you merge this Grafana to also have business metrics. You can put there things like, tie events like number of user signups, and you kind of, and for engineers it's very good because you have this holistic picture of your performance numbers and business metrics, and sometimes they're more interrelated than we think. Now, this kind of lives, I would say, these two tools, you mentioned PostHog or Amplitude, and now I'm mentioning Grafana and Prometheus, I would say they kind of live parallel to each other, right? I would say it's very common that they will coexist in your system.
Correct.
And they will serve a little bit different needs. There is some intersection, but not fully, right? Still, PostHog Amplitude focus on business events, and Grafana Prometheus will focus on these technical regressions, but they're inevitably tied to business events. And I'm just trying to give a feeling to listeners who, let's say, don't have this experience with these tools, that it's okay if these two coexist, and maybe that's even good because they serve a little bit different purpose.
Correct.
But both are important.
Yeah.
That's a little detour on or adjacent.
Completely not a detour, because data is very easy to create. It's very easy to spend a lot of money on tools and people that play and work with data.
Yeah.
It's only useful if it's used.
Actionable. Yeah. If you learn from it.
No.
Okay.
You can have a very good insight in a completely unusable tool. And then nobody's going to use that tool and the insight is not action done.
Yeah, okay. Yeah, I agree.
So that's why it's very relevant.
The tool should be usable. The usability matters.
Exactly, because otherwise it's not used.
Yeah.
And that's why you had two different tool families. Grafana is for engineers.
I agree.
You can write SQL there. Amplitude, PostHog are for maybe front-end engineers as well, but mostly for like product analysts, product owner, that type of a persona who's more used to selecting an event and the time frame.
Yeah. And I'll interject, I'll say, definitely it's for engineers because I believe strongly in product engineering, and I think product engineers should always be in touch with how users use their product. And I think this will create a better industry overall if we kind of all synergize to all care about a product. And I'm not invalidating other roles, but I think this is the one point where all of these adjacent fields should touch each other is when it comes to user experience. Because it's very important as much as possible. Of course, there's a gradient in different companies, but as much as possible to always be in touch with your user experience and customer experience and what's happening on the how users experience your product. And engineers should be very involved in this. This is just saying from software engineering side, it's very important. Yeah.
The moment when Starship started to had a service, created a service in Tallinn around the office as well, things got a lot better quickly.
Oh yeah. So own dog fooding, right?
Yes.
Yeah.
Yep.
All right. So we talked about this. To step back, right? I mentioned Databricks. You said no. Let's not use Bazooka for a small thing. And then we discussed, look, we might not need tools like Redash because if you anyway use front-end analytics, PostHog, Amplitude might be fine. Then we touched on a kind of parallel reality of engineering, Grafana, Prometheus for defining SLOs and metrics on them. Usability matters. These tools are for different purposes. So what's coming next? Let's say the company grows, problems become bigger, more resources, also more people can work on different problems. What's the next stage?
Now it starts to depend on essentially the company leadership. Some companies say that they are data-driven while they are not. And in other cases, they are too much data-driven and don't act quickly enough. So
learning too slow.
No, over-analyzing.
Over-analyzing, right?
Yep.
When they might go with intuition or just some experiments.
Yep.
Yeah.
So the better term actually would be used instead of data-driven would be data-informed.
Yeah, I like it. Yes. I remember once someone asked Elon Musk, "Are you data-driven?" And he started to laugh, like, said, "No, I just like build products that make sense."
I've seen he expanded on that answer, but yeah.
But it's true. Data-driven is a very overloaded word in today's industries. We need to understand how do we actually use it, and it's not like one hammer that you can use for everything.
Yep. So at that point of a company evolution, the business will have bottlenecks. Some of those might have data. Like if your one sales guy left, that's not a data problem. You don't need a dashboard.
Yeah.
You need another sales guy.
Yes.
So, like.
I get the point. Yes.
Yeah. But let's exclude all of those like edge cases and say, yeah, you have your product expands, you have more features, you get into, you have good engineering teams who are able to iterate with the product owners on how to go from there, what would make users convert in a better way, something like that. And then the analytics, if it's used, will become a bottleneck in the sense that, oh, we have this new feature. How did it affect something?
Yeah.
And if you still write those queries in production database, then it might get slow.
Yes. And how it affects on all levels of granularity. It might affect some of your subsystem, or it might trickle down all the way up up to revenue numbers monthly,
Yep.
right?
Yep. And then the bottleneck is analytics speed. You might have 2 or 3 analysts already in different areas, probably in customer support, in product itself, something like that. And as more and more people, hopefully the product people themselves, engineers themselves, start to run these analytical queries to understand wider patterns, then it's gonna start to affect the production database. If you only
And
do it on
we're still
production.
talking
We're
about...
still talking about that.
Yeah, exactly.
Then,
And I experienced that, by the way. So
yes.
we'll move on. That's true, by the way.
The next step is you create a read-only replica of that production database, and you're once again good for about a year.
Yes.
But eventually you will get both the amount of data goes up and the variety of data goes up, as in you will probably start to integrate some external tools. You might have Zendesk, you might have, I don't know, Pipedrive, these different tools where some of your business related stuff also exists that you want to bring in because you want to see larger patterns.
Yes.
And then you need a central place for that. And that's where data warehouse comes in as that central place.
Yes. So just to paraphrase, and for you to correct me if I'm wrong or correct, to say that with the growth of the company, you start to have different data sources inevitably.
Yep.
Because let's say even if you, from software engineering perspective, even if you don't use microservices and you still have one service, let's call it monolith or modular monolith if you do it right, you have one database there, but you might use third-party tools, and you better use them and not reinvent the wheel, Zendesk, Pipedrive, and you now still inevitably have multiple data sources, and you don't have a centralized place to query data from and combine data from all of these two or more data sources, right?
Yep.
Okay. That's when you start talking about data warehouse.
That's when you start talking about the data warehouse. Actually, a bit before that, because data warehouse is a slow thing.
Yeah.
Data warehouse needs a critical mass of data. If you import 10 tables from your production, then you might as well go and query those from your production or the production replica.
Yeah.
So, and the analytics evolves to a higher grain as well. You need to understand wider patterns, so you need more variety of data sources. And to do that, so if you run into bottleneck, okay, we want to see these patterns from 3 different sources all together in the same place.
Yeah.
That happens only when all of those 3 have been imported into data
because
warehouse.
then you can interlink and actually make queries
Yep.
that interlink 3 of them. Yeah.
And that has a long lead time.
Yeah.
You need a different software. You might have a person who's capable of doing it. Sometimes it starts as a data warehouse Postgres database, where you just use some Python or some external tool that pumps the data in there. It doesn't need to be specialized data warehouse. But it will take time, and that is the point of time when you will run across most of the very granular issues that we spoke about.
Yes.
And that will take time to resolve. And only then will you be able to start to tie these things together. You might also find out that you have no identifiers that will allow you to link those things together.
Yeah.
For example, that's
Yes.
there are many different things that can come up, and that is what makes up the long lead time.
Yes.
It's not that your software installs for 4 months.
Yes.
It's your software. You buy the software or install the software in 4 minutes or hours, but then you take 4 months to work through all of those issues to write that first query that gives you the larger pattern.
Yep. And to give practical advice, let's say, imagine we are creating this podcast as a cheat sheet for people, what to do, or some sensible defaults, right? We're not talking, we're not talking in extremes of do this or don't do that. Just for listeners, you have to always make your own conclusions and to think for yourself, and it always depends, right? So keep your context in mind and keep your problems in mind, what you're solving. But saying all of that, what would you say, given this problem of having a data warehouse? You mentioned one thing, you could have it in Postgres even as a default. What's like the next step? What would be your kind of, again, default suggestions? Which tools to explore or platforms to explore for data warehouse solutions in this point in time when you, again, already aggregate multiple data sources?
Very simple answer. Hopefully, one of the people already who's in the company and who wants to develop themselves in this area has some prior experience with some tool. Take that one.
So if that person was you, which would it be? Which tool would it be?
It depends. I've worked for a long time with Databricks, but Databricks really is a cannon. You can do many things with it.
Got it.
And for me personally, I would take Databricks because I know how to handle the costs and how it works. But I have 6 years of daily hands-on experience.
Let's say you know how to use this cannon so it doesn't shoot at your foot.
Yeah.
What are other alternatives you're aware of that you can at least tell listeners to explore as other alternatives to compare?
Yep. Google BigQuery is very common.
Google BigQuery.
Yep. And direct competitor to Databricks is Snowflake.
Snowflake.
Yep.
It's AWS?
No, it's a
separate
external thing.
Ah, right.
And there are some other tools out there as well, but that's like a AI or Google search away to explore.
Right.
What I suggest not to do is try to cobble together 7 different things yourself.
Right. So not to reinvent the wheel. Not to reinvent the wheel with data warehouse platform.
Yep.
Yeah.
Because sometimes it happens that there is a data scientist who's very fond of Jupyter notebooks, and then, let's do a data warehouse, and then there are things that kind of work in the data scientist's computer, but nowhere else, and when you get a new person, then that doesn't work out. Yeah, things can go pretty wrong.
Yeah, I understand.
And I'll bring it back to the point where your bottleneck is analytics. You need that lead time to get the data warehouse up and running.
Yeah.
And one is lead time, and the other is that during the lead time, there's a certain velocity of how quickly things move, how quickly new imports appear in the data warehouse. But one thing that I haven't really seen mentioned a lot is that data warehouse exists in a very changing environment. Because software engineering, the purpose of software engineering from this point of view is to make changes.
Yes.
Yep.
The faster you move, the faster you learn, the faster you make changes in your product, the more chance you survive as a company.
Yep.
Yeah.
And most of those changes involve data.
Yes, because you will evolve your data model, of course.
Yes,
as
exactly.
you go. Yeah.
Like a new feature kind of by definition involves some changes in data.
Yeah, I agree.
And then data warehouse is downstream of that.
Yes.
Yep.
And that's how you said the good word, and I wanted to discuss it exactly with you. You're reading my mind. And you said the data warehouse is the downstream of that data, and that's a very important topic, right?
Yep. And this is where, you might get the data warehouse up and running for your analytics, maybe even in 2 months, and then you expect that, oh, we're going to have, I don't know, a data scientist in the next 2 months building models and predicting future and so on. And then you figure out 2 years later that, oh shit, it's just that one person in the data warehouse team has spent their whole time just playing catch up with all of the changes that happen in software engineering and external tools and so on and so forth.
Yes, and I want to really, if you don't mind, let's dive deeper into this topic.
Sure.
Right? I remember we both, that's where we collaborated the most in Starship maybe. That's when you come to me and say, hey Vili, about this data model, so are you guys changing this or that? Or I think we even discussed at some point, how do we pipe data to data warehouse at some point? There were questions, do we do it through Kafka events on a higher interface level, or do we do it directly kind of piping through the data model layer? And I think we ended up with kind of directly on the data model layer. And again, as you said, you were downstream, and any changes that happened in our data model, you then had to modify ETL process in data warehouse to
ETL and to allow then the analytics to be modified.
Yes. But the good point of that is that the software engineers were not blocked by these changes. We could move the data model as we wanted, but it cost, we were a pain in the ass for you.
Yes.
And that's an interesting kind of, well, first of all, relationship, but also it's almost like an architectural pattern, right? And it has its own trade-offs, but it has a benefit of software engineering and moving fast.
Yep.
And that's a value of it, right?
Yes.
And now, but when we talk about this exactly streaming...
There is a better way, but we'll get there later.
Yes. Let's discuss it in depth. So what are the possible solutions to... Let's already imagine we have few services internally. So not only external services, let's say like Freshdesk or Zendesk, where maybe data warehouse tools already have some common importing APIs or the ways to fetch this data, because they might have, I don't know, integration with that. But if we talk about internal systems, let's say we have 3 different services with their own 3 different respective Postgres databases. How would you build piping this data continuously to data warehouse?
Well, very well phrased question. I wouldn't do it continuously. Most business analytics is fine if it knows things about yesterday.
Yes.
Yep. So that limits, that alleviates the like close to real timeness constraint. If we can do it at night or whenever the lowest time in product activities, then we can do like rougher things. Like, for example, continue importing full tables as long as we possibly can.
So let's call them like nightly jobs. Right?
Yep.
Okay.
Yep. And that should mostly cover like 99% of your needs for a very long time.
Sure. So how would you do that? If we talk about, let's say, you have your ETL code, right, eventually, that you want to import data. Would you import directly from the read replica of the database, right? And you would do it, let's say, nightly, just as a sensible default, right? So this is first sensible default that you should consider when you start to have the need to pipe data to data warehouse, right?
Correct.
So, and to give listeners, again, the feeling of the trade-offs or pros and cons here, the pros are that software engineering should not do anything while you're doing your changes in data warehouse world, so to speak. So if I change as software engineer my data model, I add the extra column, you will have to adapt, not me.
Correct. But the data engineering tools and methods nowadays take that into account. So the automatic schema evolution works.
Yes.
Yep.
Yes,
so
that's good. Yes.
If you add a column, people usually, like, I've almost never seen a dropped column.
Yeah. So let's say we don't talk about breaking changes.
Yeah.
We talk about additive changes.
That ends up in the data warehouse as a new column automatically.
Yes.
Yeah. So I don't actually need to know about it.
And it's an important point. You want to build your data warehouse pipeline so that you don't have to do any effort on your side to get this extra column, right?
Yep.
It should be automatically, because this will save you a lot of time. So you don't have to.
Yes. Once again, because the essence of software engineering is changes, and changes usually come with changes in data.
Yes.
And you don't want to wake up to like 4 changes every single day because production
Yes.
things update.
And maybe to even go into more details here for software engineers, just to give interesting bits for both. I think for software engineers, what's important to know, because maybe the first reaction when I said, oh, but you don't do breaking changes, but the first reaction might be, but wait, but we need to change this data model. Yes, don't be constrained. Let's say, but the key word to keep in mind is you can do a multi-phase migration of your data model. For example, I want to actually change the structure of my table or create different columns. Imagine our understanding of the data model improved. We know we actually need to change our structure, schema, because of whatever reasons, performance reasons, or a better explicitness of the domain. Then I think the important thing, you can do these changes in multiple phases. So you leave, for example, the current table and don't break the processes for data warehouse. You create extra table, you write to both, which means data warehouse is not broken, you are not blocked by data warehouse, and you already, in your process, you already migrated to the new one while writing to the old one. And now I talk to Lauri and I say, look, Lauri, we still write to the old one, but whenever you have time, you can start changing your ETL process to read from the new one. But this is why I call this multi-phase migration, and it's so critical skill to have in engineering, is you can make this apparently, from the first glance, drastic changes, but in multiple small phases, so you don't break processes or other teams around you, and you still retain the properties that you are not blocked and the other team is not blocked. And I think this is an important thing to mention as well.
That's one option.
Yeah.
There is another.
Exactly. Yeah, there are many options here. How to
in general, the other option is that you speak to people beforehand and then you do your massive breaking change and everyone knows and fixes it within 2 hours.
Yes, yes. But in reality...
It only scales to so far,
yes,
yeah.
Yes, yes. But you're right. You can speak, but then imagine that if, let's say like this, you have to be adaptable and agile to act or choose different strategies based on the result of that conversation.
Yep.
Because I can speak to you and you could say, yeah, you know, Vitaly, we have completely other priorities. Then I will adapt, right? Or you say, yes, Vitaly, let's do it just right now together. We could pair, you know, or tell me which changes you do and we do it in lockstep. And this is completely fine.
Yep. And the thing is, data warehouse, if we import once a night, then if the data breaks during the day, then it doesn't affect anything.
Yes.
So if I can do the change during the day as well, and the import, I test that it succeeds, and the analytics on top of it is changed as well, then it's okay again the next morning.
Yes.
Yeah.
All right.
It's one option. Smaller team size, so the communication is there. But yeah, you don't have to involve a huge machinery to try to mitigate that on a technical side. You can do sometimes these things just at the same time.
Yes. So you rightfully mentioned that there are other options. Do you want to discuss them now?
That was the other main option.
Oh, right. But did you mention other options of piping the data to data warehouse?
Right.
If that's something you want to delve into.
I can briefly, because
yeah, we can do briefly. Sure.
The full import cannot work for a few different reasons. And all of those reasons have different solutions. One thing is just way too much data. Usually that's not needed, but it might be that you have a large, ever-growing table somewhere that someone that now is the time to look at the patterns there. So it's not a thing that started to grow from last week, but has been growing for 4 years, and now you want to get it into data warehouse. And it keeps growing by like 10 million rows per day.
Yeah.
And those have different options. You can do like incremental imports. You can do CDC, which is an acronym for Change Data Capture, which is a pretty mature technology nowadays. It works based on inter-database like synchronization logs, and yeah, it's a whole thing.
And it's this change data capture. This is the technique when you import data to data warehouse.
It's a thing where you import the changes and then you apply the changes. Yep. So if you have a 2 billion row table that you only insert to, then the changes are the 10 million rows that you inserted yesterday. So I can import those and apply those to my data set in data warehouse. And that's one of the most costly ways because it involves multiple steps.
Yeah.
The main thing, though, is that the easiest is to do incremental imports, which has a very clear precondition that I should be able to understand what changed recently.
Yes.
And that's on the production database side. So that's one suggestion to software engineers: always have a updated at or updated timestamp.
Because then you can sort by it, or
Then I can sort by it. Then I can only import the things that were updated within last 48 hours, for example.
yeah, or a little detour, but you can consider even other architectures. But again, I didn't say you should, but you can consider things like event sourcing or keeping history, where you know that the previous entries never change. And based on that, you can build a lot of cool invariants where you only always want to process the new data. And you never even look at the old data because you always know that it's immutable and they never change. So that's, again, another patterns you can consider when you build. But again, those patterns, like there are many books written about it, about event sourcing or other things. So apply with care and understanding. So that's a disclaimer.
Apply with care and understanding. And I would add to it that even though we're talking about what like software engineers should know about data engineering and data engineers about software engineering, then based on my experience, doing drastically different architectures in software engineering to help data engineering is usually not necessary.
I 100% agree. I think 100%, and to even stress your point, in software engineering, you always want to optimize your data model and your domain model for the production and your business use cases that you're solving. 100%. And I would say if you optimize for data warehouse, both parties will be unhappy because you will eventually not be able to satisfy requirements in data warehouse, and you will degrade your system where either performance will suffer or understanding of the system or maintainability. Yes, so optimize fully for your production and software engineering needs, and let the data warehouse do their job. But of course, you have to be sensible, and even for yourself, have things like updated at or other things that make sense for tracking of changes over time.
And data warehouse is meant to work with very large amounts of data and optimized for it.
Yes.
So if that can be solved with running an expensive query once a day, then that's what data warehouse is for. And if it solves that, and to like reduce the cost there would cost, I don't know, 2 weeks of software engineering time to change to whatever things around, that's definitely not worth it.
All right, so we discussed this. Still, like you said, other options, and we discussed, well, first this nightly jobs, and then again, if it crashes or has problems, scalability problems, you can apply change data capture, which is more complicated, or incremental imports, which is easier if your data model allows you to do it because you know
Yep.
deterministically when the new changes happen. May I ask a question?
Sure.
What do you do when you right now, in the phase of the growth of your company, already need near real-time data? And I mentioned near real-time. Let's be realistic. Let's now say we want, from business perspective, to capture all these events, especially business events, in our data warehouse, let's say with a delay of, we could talk, it's a gradient, but let's say 10 minutes. 10 to 5 minutes, right? We are not talking about near real time in 1 minute or sub 1 minute, because this, again, this is where, you know, the less time, which might affect architectural decisions, right? A lot, especially in production systems, right? But let's talk about something sensible and realistic, like a 10-minute delay first.
Okay.
Or what do you think to explore that?
I can explore that.
Because I've seen and experienced such constraints or requirements. Of course, they come with the context of which exact problems we are solving.
Yep.
But still.
I'll give my answer, and then I want to know your context,
Sure.
where it makes sense. The thing is, it's from data engineering and data platform perspective, it's a very short answer is that, like, what's the use case? Because for things like why we do the whole thing is that someone can make a better decision.
Yes.
Right.
Yes.
A human will never make a decision every 10 minutes or
Yes.
with a 10-minute delay.
That's a very good point, yes.
Right. So there is actually no use case for that. So then we are starting to talk about machine decisioning.
Yes.
But that's a whole different area.
Yes, because that is actually related to now production system, as is more of a realm of software engineering as well.
Yep,
because
and machine learning engineering and that whole area. Yep.
That's a very good point.
Yeah, I'm completely avoiding the topic. Because
no, you're not. You're not. You're actually answering that.
I'm answering that because the technology is there. You can. There is a very many opportunities to pay a lot of money to achieve that, like a 10-minute delay or even like a 10-second delay.
But the question is which problem you're solving.
Yes, right. Because data warehouse is the wrong tool.
Yes.
If you have the need, then data warehouse is not the answer to that bottleneck.
I love your answer, Lauri. Actually, it was kind of I wouldn't call it tricky question because I didn't want to trick you. But I kind of came up with this almost random constraint. And when I say we had this constraint or I experienced it, I experienced the requests. Like, you know, can we make it faster or how much faster? And it comes from business people. Because why? Because they naturally want to know about things fast. Yeah.
Yep.
But then again, it comes to the context of the problems we are solving.
And that's where the mental model, the four corners of technical monitoring, business monitoring, business analytics, and technical analytics comes into play.
Yes.
And
you very well mentioned the distinction, analytics and monitoring.
Exactly.
Monitoring is for near real time.
Yes.
Yes. So let's delineate these two. Monitoring tools, even the tools like PostHog, you could say. I would even say they could be, because as you said, they're also near real time.
Yep.
So they are sort of in the gradient of monitoring even. And we have PostHog, or what was that, Amplitude. And then you have analytics tools. And as you very correctly said, and I really liked it, is that if you want to make decisions in 10 minutes or less, again, human is not capable to do it like in the loop like that, then maybe the data warehouse is the wrong tool for that, because most likely it will be a machine that will be a software that will be making these decisions in the near real time. Or if you have monitoring, well, then those needs are different. This is either about alerting or, monitoring.
Yep, observability. Of what's happening in the real world.
Yes, yeah. I love the answer. Very, very good. Where do you want to go now from this? Do you want water, by the way?
I still have some.
Okay.
I want to cover one last aspect of this that you mentioned as well, and maybe we can take a break and then continue.
Sure. let's do it.
The one last aspect was that you mentioned that in Starship we spoke about this topic on you make changes, stuff breaks for
We
us.
touched it.
We touched it,
in the
yes.
kitchen.
You actually solved it as well in Starship, which is that, and this goes into the domain-driven design and microservices. So you have the microservice, it has a Postgres database, it might have 20 tables, and let's say 7 of these are relevant for some business analytics. And that's just the nature of how you've built that microservice that the data model is spread around.
Yeah.
Yep. Given that baseline, it's actually, in reality, business analytics deals with business events.
Yes.
And quite possibly there is 1 or 2 relevant events that happen within the product functionality of that microservice. It might be a payment gateway, it might be, I don't know, robot routing service or whatever. For the business, it's this thing did that thing at that time, or some state changed.
Yeah.
And what you can do and what you did as well was that you essentially started to produce a secondary data set that was business events. And that was one data set. And we imported that one data set that had all the relevant business events, but it was a single data set, essentially like 5 fields. What changed for whom, when, into what status, something like that.
Wait, and who created those business events table?
You created it.
Well, probably not my team because I was in
Yes, your team.
fleet orchestration.
Yes. You started to produce these business events or whatever the analytics events were into Kafka.
Okay. Yeah.
And then
okay. So we talk about Kafka layer now. The messages layer.
It can be Kafka. It can be a separate table that just contains the same data.
Yeah. I'm just saying it because I think we did not persist it in the table in the sense of Postgres.
It doesn't really matter.
That's why I got confused. Okay. Yeah. But yes, we produced then Kafka events, and then you just coupled to those Kafka events.
Yes,
so
we changed all of our analytics to query those events instead of the 7 tables.
Yes. So, and that's exactly the good point, and I wanted to discuss it with you, because very good that you mentioned it, because we talked first about the piping of data from directly the database.
Yep.
Right? But now we are talking about pretty much application layer and the business layer of let's define events, and the production system will publish these events.
Yep.
And data warehouse, as one of consumers, maybe there are others, will consume those events.
Correct.
Maybe other consumers might be, for example, machine learning systems in production that care about those events, and they do some actions or online active learning on top of that or whatever. Very good point. So that's another pattern.
It's another pattern, yep.
Yes.
And the effect of that pattern is decoupling.
Yes.
Because after you did the change, it took a couple of months for the analytics to migrate over to using these events and not use the base tables anymore. We stopped importing the base tables. I think we imported all 20 anyway, even though most were not used. And then we stopped doing that, deleted that data, and then we were fully decoupled.
Yes.
You were able to continue iterating, writing software, enhancing the features and so on within your own microservice.
Yes.
Without being causing downstream trouble.
Yes. And I wanted to, again, I'm so happy you mentioned it, because this topic is very relevant for engineering, because remember when I mentioned about multi-phase migration, when you do changes to the data model, because you have to be careful when you do it, because again, you can break things. Now, when we move the layer up, and now we talked about on a contrast about event-driven architecture, where we publish events, you consume them.
It's not event-driven yet. but it's a technicality.
Sure. Let's say, but we publish business events that you care about,
Yep.
and you consume them.
Yep.
But now what we did from the coupling point of view or decoupling point of view is suddenly your system is not coupled to our data model.
Yep.
It's completely encapsulated away from you. And what we can do now, we can drastically change the data model
Yep.
as we want, even
You
overnight.
can drop all of your tables if
Yes,
you want to.
as long as we keep the promise of that interface of the
Exactly.
Kafka event that you couple to.
Yep.
So now we moved coupling from the data model to the event, which is a contract for us
Yep.
right now. And this is a good thing when you grow as a company, because this gives you more freedom. Again, if we talk about software engineering side, this gives you much more freedom from software engineering point of view to evolve and move fast.
Yep. Essentially the same thing. You can have microservices on top of a monolithic database.
Sure, but I wouldn't recommend that.
Yeah, I would. I mean, that's how
There's, by the way,
reality happens.
A whole book, but by the way, there's a whole book by Sam Newman on building microservices that I recommend to read, which goes like, again, if you want to go into this rabbit hole of pros and cons of database integration and building microservices on top of that, which is usually, by the way, considered anti-pattern. We don't have to go into that because, again, you might do it right if you decouple things also on a database layer and you split into logical separate schemas, which essentially, technically, you have one cluster, but you have separate schemas. But in practice, if you don't do that and you have different microservices that couple to one database, you have other, let's say, software engineering problems. Let's not go into that. But I'm giving a reference here for listeners. There are many trade-offs to consider here, and book by Sam Newman, Building Microservices, is one good reference for that. Or you can just Google pros and cons and different trade-offs of how you organize, how you integrate between microservices, pretty much. But this is a
but the same principle of you need decoupling,
yes.
so you can iterate faster.
Yes, and exactly. And the problem, if you have one database and multiple microservices sitting on the same database, is exactly that now each microservice, especially if they write to the same table or read from the same table, this is now a disaster, right? So this is why I'm like, whoa, let's just mention this to the listeners.
Yeah, it's exactly the same principle.
Exactly the same principle.
In the monolithic database case, you break production.
Yes.
In the other case, you break data warehouse.
Yes.
But you can decouple this by essentially building business events and publishing these. And working and talking with your data people.
Yeah. I'm very happy that we touched this topic. Let's make a small break.
Yes.
Let's do it. So, we had a little break. Maybe let me make a quick summary of what we discussed, right? Well, we started with your own context and discussed how you worked in different areas. Starting actually as a software engineer, you worked in Skype. And you worked in, there you did some machine learning even. And then you worked in Starship where you had to deal with massive amounts of data, right? And then we started with you to systematically think about which problems companies experience, starting from smaller size to bigger size, and how the data engineering needs evolve there and problems become...
And analytics,
And analytics, yes. Because the problems become more involved and different ones, and which tools we can use and mindset and principles to use to solve them. We started with the fact that first, there's no need to use anything, even like Redash for analytics. You can do it in your pretty much front-end monitoring tools or analytics tools, tools like PostHog or Amplitude. We talked about how it interplays with tools for other needs, like technical needs, so Grafana, Prometheus, to set up SLOs and alerts there. And then we had a full-blown discussion about how do we, once we have multiple data sources, how do we create a data warehouse? What are the options there? For example, first you can even start with vanilla Postgres as data warehouse. You build ETL on top of it. And then you can explore solutions. You can use a canon like Databricks if you know how to use it. And that would be your choice because you're very experienced in it and you know how to use that tool. But you can also explore tools like Google BigQuery or Snowflake, and I'm sure there are many other
Yep.
that you can just explore yourself and do the analysis. And we discussed a lot, again, about the whole ETL process. And there we discussed first piping data directly from the data model or database from your read replica and building ETL on top of it. There you can do it first in nightly jobs. If that doesn't work, you will employ techniques like change data capture or incremental imports. And for incremental imports, it's important to keep track of, again, timestamps, like updated data.
Yep. So that you can understand what changed.
Yes. Then we discussed, and I asked you a question, but what if we needed real-time import into data warehouse? And I really liked your answer where you said, if you use data warehouse, which is for analytics purposes, as the tool to answer questions on the data, which should be 10 minutes or less fresh long, right? Then probably data warehouse is the wrong tool, right?
Yep.
Then you can resort more to the monitoring tools, like, again, PostHog or others, and use analytics, again, for humans. And if you build this, what you call data-informed company and mindset, then it's okay if the data is not near real time or so fresh as, for example, 10 minutes.
Yep.
And we talked about decoupling of the data piping from production systems to data warehouse, not to do it on a database level, but to move layer up and do it based on events, business events. And there you can employ tools like Kafka or any other messaging system. Google pops up or whatever you have. But that creates really good properties, at least for software engineering, where you are not coupled to our data model, which means we can evolve it as we want, as long as we keep the interface intact that we agreed on.
Yep. The term for that is data contract.
Data contract, yeah. The term in data engineering,
Yep.
Data contract. All right, so...
I'll touch very briefly the things that we didn't talk about and
Sure.
we're probably not going to talk about.
Let's do it. And let's save it for the round 2 of our episode.
Sure. So we almost didn't talk about when and how machine learning comes in.
Machine learning.
Machine learning, what the data science workflow is,
Yeah.
how machine learning models do predictions in real time in production, how that happens, what's machine learning engineering, and feature stores and all of those topics. We didn't touch any of that, and this is all like downstream from there, because unless you are a very specifically in that niche where you need or offer those things, then you don't need to go there.
But Lauri, now I'm more than ever more interested to invite you again so we could discuss that as well. So just saying. But maybe one topic that I think is related to today's discussion and focus is to talk a little bit about GDPR and data compliance, because this is exactly the topic that relates both to software engineering and data engineering. And this is where the intersection is also quite strong. And why I'm asking you this question, because I asked my friend what he would ask, you in the episode, and he answered me that, yes, he's interested to know, and he gave an example, if you have event sourcing system, right, production system, and then you suddenly have a requirement to delete data. And he mentioned very correctly, he said, not just marking it as deleted, but actually delete the data, which is an important distinction. We are not talking about soft deletes where you just mark it as deleted, but to actually delete the system. Which principles would you say are important to follow given the today's age of data privacy and GDPR rules from the data engineering perspective?
I'll just start. There is a way to build a data warehouse where you don't care. In the sense that business analytics, data warehouse, and data engineering in the context of data warehouse is for business analytics.
Yes.
And business analytics, usually doesn't care about an individual.
PII.
PII, yeah. About their name, their IP address, their, I don't know, whatever personal attributes they have, their home address, and so on and so forth.
Yes.
Yep. So business analytics usually doesn't care about those things. So it's possible to have a data warehouse that doesn't have any data that would fall under GDPR. So just avoid the whole problem.
And this is what you would recommend as a sensible default. Because if you start with that principle in mind,
Yep.
it's easier rather than to then fix it retrospectively when you suddenly need it.
Yep. And within that context, like in production, you need to know the usernames and addresses and so on and so forth. I don't know exactly how to solve that, but I've heard of services that are like essentially PII service, that you have a singular place in production that contains the customer information.
Yes, this is, by the way, a very good point that you mentioned. So maybe let me give you my lens on this. Yes. And let me tell you first how it happens in practice. In practice, engineers don't think about it, and neither do PMs because they forget about this problem. And you build your data model just as always, classically, until this problem appears.
Yep.
Until you are either big enough or you start to have this problem or you need to do some audit or whatever. Then you think, okay, given what we have right now, how do we make it happen? This is what happens in practice.
Yep.
Now, you said it very correctly that you might avoid this problem from the start, and you have to be conscious about it. And I would advise this approach as well. So my advice, of course, apply with care, but think about this problem from the start to just agree on certain principles in your system that will allow you to have and what the important word here is clarity and visibility, right? The worst thing you can have is where you don't have even yourself idea where your PII data lives. So this is baby step number 1. Understand where your PII data lives. But now the step number 2 would be, as you said, and in software engineering we would call it like create the encapsulation layer that gives you strong control over this PII data, which then allow you to apply different operations on it. And again, this operation, one of the operations might be to delete it in a way that doesn't break your system. And yes, PII service, for example, having encapsulated service, and again, talking in software engineering terms, it doesn't have to be a separate microservice. It could be a separate module inside your, monolith or whatever. It's a technicality, but yes, create encapsulation or understanding where you put PII and having granular control and understanding and visibility how you change it, given the requirements. Maybe you need some audit log or specific even accesses to that data. That's also important. Yes. So you have to consider access and authorization to that, auditing, and then modifications, right? So deleting, modifying, who can do it, and it's all interplays with authorization and everything. So, and I would say that's my only advice. If you just be mindful of these requirements and things, and yes, if you do it from the beginning, this will pay off a big time.
Oh, yeah.
Yeah. So,
like even way before data warehouse gets into play.
And even for yourself, because most likely if you operate even in Europe, but I'm sure in US and other places, from the start it will give you peace of mind that you have a good grasp of this data or control and visibility, and later on, if you will need to pass some certifications, audits, compliances, you already have the necessary fundamental foundation to do whatever extra requirements or changes that will be required of you. Good. Yeah. I'm very happy we touched on this data compliance topic. Anything to add from you?
I mean, that actually doesn't answer the question because that's not what the real world usually looks like.
Yeah, but then, yeah, the de facto would be, let's say, if you're in the real world and then you need to comply to requirements, Well, then honestly, you deal with your context and your problems, and then the only answer is it depends. Now you have to understand your system the best,
Yep.
and to understand which changes you should do to satisfy the requirements.
Yep. It also like which terms and conditions your service has on your website, which version of the terms and conditions the
Yes.
customer actually accepted and what it applies to them. What can you use the data for? It's a huge rabbit
Yes.
hole.
And it will most likely require cross-team alignment or vision. And again, this is why it's easier to do it in the beginning, because most likely, I'll give you an example with the PII. You may think, oh, it's probably just about what we store in the database. Wait, what about logs?
Yep.
Now, if you log PII data and you haven't had a principle that you never log PII data, now you have a problem of logs. But wait,
Yep.
you store logs indefinitely. Now you need to have a logs retention policy.
Yep.
But what do you do if you have an on-demand request to delete a customer data and it's in logs? Have you implemented the methods to just delete those things from logs? Well, it's going to be pain in the ass to implement that. So maybe what you need to do is first agree as a principle, we don't log PII data,
Yep.
but we redact it, anonymize, whatever.
Yep.
And by the way, on anonymization and pseudonymization, you can have techniques to still sometimes retaining the ID, even if it's fictitious, is important. So you can have different techniques to anonymize PII data to some pseudo IDs or IDs.
Yep.
That will give you continuity if you need to, for example, trace this person without knowing this person
Yep.
over your trace in your production system. So
Yeah.
this is one technique you can use. So almost always you never have this hard requirement that you need to log PII data. You can always convert it to some redacted version or anonymized version of that.
Yep.
So
But yeah, it's a very deep topic.
yeah.
I understand it to some extent, but yeah, I'm also seeing what the data protection officer type roles do, what InfoSec people do, and how it all plays together. So there is it's a pretty interesting world, and that goes like the overall terminology for this area is data governance.
Data governance.
But data governance is super wide. This is a small part of data governance.
Yeah, but very, let's say, ever-growing in importance topic for IT companies,
Yes.
right? Yeah. All right. To wrap up, can I ask you some flash questions?
Sure.
So it's just a little game. Again, no tricky questions, hopefully. But you can reply with, 1, 2 words or one sentence or so. So quickly, right? What do you use for data visualizations usually? Yourself, not talking in generals, but yourself.
I do it in Databricks
Databricks. Right.
as I use it. And I half the time actually don't visualize.
Right.
I just write like exploratory queries where I keep modifying the query until I get the answer that I'm looking for.
Right. Where do you usually crunch your data or analyze data if you need to do it manually? Is it Python, Pandas, or what is it? The tooling that you use on a daily
Excel.
basis? Excel.
Yeah, I mean, if I have a text that I need to split into columns
Right.
and then summarize something, yeah, I don't. It's so much easier to do in Excel or
Right.
Google Sheets.
And if Excel doesn't do the job, what do you use for more heavy weightlifting?
Databricks.
Databricks. And in Databricks, you use Python, Pandas?
Yeah, Python, yeah.
Uh-huh.
I actually don't use Pandas at all.
Uh-huh. Okay, cool. What are some of the books or resources in data engineering or data science that affected you and you loved that you could recommend to the audience to check out?
Should have seen that one coming.
Something that comes to your mind. It could be books even outside of data engineering.
It's
on life.
The data world has one main Bible. It's called Kimball because Kimball is the author.
Right.
It's the essentially like fundamentals of data modeling or
Right.
something like that. It's a huge book, and it's very good. It gives these kinds of
Fundamentals of data modeling.
fundamentals, essentially, like what are slowly changing dimensions, how to think about those, and what are the 7 different ways to handle those. Like when, I don't know, even a stupid example, like when someone's last name changes, how to handle that in your
Oh,
data.
right, okay.
Like slowly changing things.
I see. I will give the link in the description about this book.
Yep. It's also very good for a different purpose. It's if you can't get sleep, it really helps.
I see, yes. Makes sense.
It's very dense, but also very good.
Any other resources or anything you would recommend audience to check out?
Depends on the interest. I actually don't recommend sources. I have quite many people ask me like, how do you get started with analytics? My answer is always with a hobby project.
Right.
Like everyone has a hobby, and whatever hobby you have, there's data about it.
Yes.
Even if nothing else, there's data about, I don't know, the hobby groups or the gear that you need for that hobby, or I don't know. I played disc golf. It's not very data intensive, but there are scores and there are discs and so on and so forth.
You stole my next question. I wanted to ask, what's your hobby? So disc golf it is.
Disc golf, yeah.
In Estonia, it's a very popular sport, right?
It is.
Yeah. And I know you won some competitions in disc golf, right? So you
A
became
long
rather
time
good at
ago,
that.
but yes.
Cool. Yeah. Anything that you would like to say at the wrap up before we finish to our listeners?
It's been a good summary, as in we didn't leave a lot out of it. So just retrospectively,
It's good fundamentals, right?
it's good fundamentals, yeah. And all of these are like, you can go into that area. It splits into 100 different sub areas, and you can do PhD in every sub area. But we covered most things at a pretty good depth without going too deep into any different area.
Yeah.
And we covered vast majority of what like people in data do up to a company size of, let's say, a few hundred people.
Right.
Yep.
Yeah.
When things get international and way larger, it changes.
Yeah, and you will have people who will know much more about than what we discussed in this podcast, who will advise you how to do things, right?
Yep.
When you grow at that
Yep.
at that point.
And you had a chat with Joel as well, and he's in Microsoft, and they're building things. And even from his talk, it was obvious that, you need like 6 months of understanding the thing before you are sure you can make the correct changes there. And that's a very, very, very different world.
Yeah. May I ask, I know you have a podcast that you run with your business partner. Can you tell listeners, if they want to know more about data engineering and deep dive into other topics, where can they find your podcast?
The podcast is in Estonian language.
Right.
It's called Laomees ja torumees, which translates into warehouse guy and pipeline guy.
Nice name. Cool.
It's on YouTube and Spotify, and we post links to it on LinkedIn on a weekly basis.
Cool. Yeah. Thank you, Lauri. And I want to say you're not only a great data engineering lead and thought leader, and really, sharing the knowledge, which I think it's very cool that people like you do that. So I want to thank you for that. But I also thank you for being a very good friend of mine. Thank you for that as well.
Thank you as well.
Thank you for this podcast episode and being here.
We can cover other topics in future.
Let's do it.
It feels like there's material for more. Thanks.
I hope you enjoyed this podcast episode with Lauri. And to give you a sneak peek, the next one will be with Anton Keks, where we both will discuss about some of the inefficiencies and anti-patterns in software engineering. For example, we will be discussing things to avoid when dealing with PRs or maybe even avoiding PRs if possible, or as one model. We will be discussing the anti-patterns related to microservices and some other things that we see are not working well in software engineering industry as a whole. Yeah, I hope you will enjoy that one as well. It's coming out soon. Thank you for listening to Map for Engineers.